The way the capacitance keyboard works is that each key has a plunger. On the bottom of the plunger is a little piece of foam and a piece of aluminized mylar. And the aluminized mylar comes down onto these pads, these two semicircular pads, and makes a capacitor across the two, call these two plates of a capacitor. And it's about 20 picofarads. The keypads are arranged in a 12 by 8 matrix electrically, but not physically. Each column of the matrix is driven by an output from U5. The columns are selected sequentially by the A0 through A3 lines. After a column is selected, a strobe pulse is applied to the STB input of U5. This sends a pulse down the selected column. Any keys that are depressed in that column cause the pulse to be transferred through the capacitor caused by the key depression to the receiver IC on the right, then to the corresponding KD output line. This technology was used on keyboards of many different manufacturers' devices from about 1980 on, but most modern keyboards use conductive membranes with resistive instead of capacitive switches. But the problem with these keyboards, this one is about 40 years old, is that the foam has become so soft and deteriorated that it just compresses down, and the key might work at first, but then the foam compresses and the key doesn't reach the keyboard anymore, reach the circuit board with the pads on it, so the keyboard malfunctions. So the only way to fix this is to repair each individual key. These are the plungers from the keyboard, which have foam holding a piece of aluminized mylar, but the foam is deteriorating. So what we're going to do is clean out the foam. Inside this white plastic plunger is a clear plastic disc, which was the base of the foam before, but we're just going to clean out the old foam. Now we're going to attach a couple of these self-adhesive discs that were cut out of a sheet of foam which has adhesive on one side. This came from Michael's craft shop, and we cut the discs out with this punch from a set from Harbor Freight, and this is a 7/16 inch, which seems to be almost exactly the right size to make these discs with. So I have to remove the backing from the disc, and then just going to stick it into the plunger, centering it appropriately. So now we have a disc on the plunger side. Now, here's the old aluminized mylar disc. I'm going to very carefully scrape away the leftover foam. You don't want to scrape it so much that you remove the aluminization. I'm not sure which side the aluminization is actually on. Now we get another one of these discs, little discs, pre-cut discs. Take the backing paper off. Now, I'm going to carefully center it on the disc. Stick it to the disc. So now luminized disc is on this. Now, all I have to do is glue that disc onto the other disc, the back sides to the back sides with a drop of super glue. So now we have a completed plunger ready to reinstall into the keyboard. Now all you have to do is just repeat this 70 some times to fix the entire keyboard. These plungers, once they're done, don't have as much give. The foam is much stiffer than the original foam was. It doesn't want to stay together. So the keyboard feel will be different, but at least the keyboard will work. The next step is to pull the key up. Lost the spring. Push out the old plunger. Take a new plunger, the repaired plunger, put it back in the slot, and these have one particular orientation, and they sometimes seem to just snap in, other times it takes more force. Now I need a spring, and put the key top back on. Push it down. This is the testing setup I created. Has an AVR processor driving the strobe lines, or the column select lines, all patterns, sending a binary 0 through 11 to the column strobe lines, the keyboard. So this is the scope output, looking at one of the column output lines for the decoder, column output decoder. When I push a key that's in that column, then see the top trace is the output of the decoder, the bottom trace is the most significant bit of the column select. So I push the key, the top line, you see the signal, or the top line goes low for that key. One key in that column, different key in that column, comes at a different time. A different count on the column select lines. After I reassembled the keyboard, having, I thought, thoroughly tested it, discovered several keys still weren't working. And the reason was I had reused the foil from the old keys, and some of it, you notice this one has a kind of a mottled appearance. It's hard to see, but the luminization is either worn off or chemically evaporated or corroded off, so these keys wouldn't work. But I discovered that what I could do is use foil from a package. This is from a food package, and stick it onto the foam, on the adhesive side of the foam, and then punch out little discs like this, and use those as the bottom part of the keypad, or the switch assembly. So I did that for several switches that I had to repair. This is what the plunger looks like with one of those pads punched out of the adhesive foil, or the foil adhesive pad combination. I wished I had thought of this earlier when I was doing all the rest of them.